Hi, today I'm going to be looking at this Sony CMT-EX1 CD player from the early 2000s. Now the owners tell me it blew up on them, so let's dive in and take a look. Okay, so, yeah, as the story goes, my colleague's son's girlfriend's friend's daughter's cousins, you know, that connection, bought this Sony vertical loading CD player off eBay. It's a CMT-EX1 compact component system. It came with the main unit and then the two speakers. They loved the look of it, so they bought it off eBay, got it shipped over, and plugged it in, and well, this might give you a hint of what happened, because we don't live in the States, and this is a, yeah. So if we have a look on the bottom, we will see that this unit only supports 120 volts. It does not have a 120 to 240 switcher, and it is not multi-voltage. So yeah, they plug this in through a converter, and pop goes the magic smoke. So ask me to take a look. Let's crack into it and see what we've got. Looks like this would just... oh, it just lifts up. Great. Okay. Well, there's a chunky heatsink. Oh yeah, magic smoke smell. God. I kind of miss that sometimes, when you don't have anything exploding for a while. There's a bit of the mechanism for the CD eject. Nice. Okay, there's that module out. Ooh, that is dusty. So that'd be the power amp module. It looks like. Is this a connector? Or is that? Yes, it is. Nice. And these as well. And they're all polarity marked or keyed, which is fantastic. So yeah, there's our power amp module. Looks like it is a LM1876TF transistor. Got a nice, that looks like a relay to prevent speaker thump when on power on. And a decent amount of good filtering caps, which is good to see. Yeah, good Nichicon brands as well, and these are the Muse, so they're actually audio rated caps. Very nice. There's our motor with a pretty loose feeling belt. So I might actually replace that while I'm in here. And just a absolute metric crap ton of dust. That is insane. So yeah, we'll clean that up. I'm just going to get it past a bunch of screws. Alright, and this looks like there's a ribbon at the bottom here for the optical. And this cable for the drive motor, so that's the CD mechanism. Very nice. In. Okay, then there appears to be a ribbon going through the bottom here into what I'm assuming is this power supply module. So it actually goes up through the case and into this connector here. So I think we should just be able to pop that out like that. And then the main power board can come out, and we've got a little ground lid So we can disconnect, and that's the control. That's the brains of the baby. Hopefully nothing on there has popped, and we're just looking for power supply faults. Okay, now we're down to the nitty gritty. It looks like we've got output and power. There we go. Okay, we are in. Yes, this is indeed the power supply module. So, now this hasn't been plugged in a while, so it should be safe in here. But, as always, I just want to give the warning that if you ever do pull apart a power supply, there are big capacitors in here that will hold mains, and they'll hold it for a very long time, so be careful. I'm doing this because I kind of know what I'm doing. I mostly know how to be safe, so yeah, if you're not sure, don't do it. Okay, there's our mains lead and the back panel with the offending cord. Let's pop that off to the side. Let's take a look. Okay. Has it blown that fuse? Visually, it looks like it's fine. So let's just double check it. Yeah, no, that's fine. So it didn't pop the fuse. Let's take this board out. This is the outputs. Looks like output filtering of some kind. Yeah. Reg board. Some kind of a 7805 power regulator. Anyway, let's pop that over there and see what we've got here. So, yeah, as I said, this does have the magic smoke smell, so something let go. And we will need to find out what it was. None of the caps on here look like... Oh, no. Take that back. I think that is our offending unit. That capacitor right there has blown its top. And I'm willing to bet that is our input filter cap. And yeah, the whole inside here, you can see all over here. You can see that liquid there. That's the electrolyte that would have spewed out of this as it tried taking 240 volts. When it's only probably rated, I'm going to say for, 200. I can see it there. 220 microfarad, 200 volt. Yeah. Now, the question is, did anything else pop, or did it just die open circuit quickly? Great question. I'm going to wipe up my hands because this feels disgusting, and then I'll probably take the board out and give everything a clean down. Actually, let's just do that first. Yeah, everything on here is just absolutely coated in gummy electrolyte. And, yeah, so there you can see the 200 volt would have taken the entire force of the 220, 240, whatever we have. Oh, that's nice. And we've got, it looks like, it actually lists what the power rails that this should output. So we should actually be able to test this out of the system, which is nice. Well, let's get that out. I'm assuming if we test it right now, measure, we will have an open line. So let's check that. Yeah. Pretty high resistance. It's not open, but it's not, yeah, it's not great. At least it's not a short circuit, which is nice. So I reckon we take that out. Let's just, yeah, let's whip it out real quick. Oh yeah, and I just noticed on the top of this board, you can see this is the case above the power supply, and yeah, that spot right in that corner is literally where that cap lives, and you can see all that juice sprayed up in there. So that's definitely our culprit. There we go. I'm And let's clean up the pads. Well, let's see actually, first of all, do we have something that we can replace that with? Okay, let's see what we've got in the tub. Yeah, okay. Alright, what else do we have in stock? These are all too small. There we go, 680, 200 volt, maybe. And that's another one, 680. Yeah, that may just work. At least for testing. Well, let's give that a shot. And if that works, I can yeah, just get something better, something more appropriate sized, and I can even do some research to see if we can replace it entirely with something that's 240 mains rated, so they don't need to use an adapter, which would be nice. Okay, so she's in. Now, what to do, let's figure out how we're going to test this. So I will need to get the mains cable back out on its plate. See if I can, it's probably easier to leave that as is. Just flip that around like that. And we can plug this into our, I've got a, like I said, a step down, which will give us the 120 volts that it needs. And then it looks like we can just test those pins on the end here. So I'll hook up, I'll probably run it upside down like that so I can read. And then I'll hook up, yeah, different voltages and see what we see. Okay. Let me organize that. Okay, so I have my little 240 to 115, 110, 120, perfect, step down transformer. Good thing is this, you know, it's rated for 50 watts, but this unit, I don't know where the bottom is, I think it's under there. Anyway, it's rated at 40 watts, so that's perfect. And what we can do is I will run this through my little, this is a dedicated circuit breaker. So I can plug this into here, and then I can test and have this blow instead of, you know, knocking out the entire house if this goes off again. I think we're good to go. So let's get these all plugged in and give it a shot. So we have this here. There's our test points on the end here. Power. Let's hit the button and see what happens. Alright. Nothing's exploded. Seems fine. Alright. Let's check if we have some voltage. No. Oh, that's DC. There we go. 120 volts coming in. Great. Alright. Let's see if we get... we've got analog ground here. 7.2. That looks good. We've got 7.5 volts there. 7.3. Yep. 10 volts. I think that's it. Okay. Now, it's all back together nice and loosey-goosey. Let's give it a shot. Yeah, look at that. We've got power, CD. The display is pretty weak. We've got tuner, tape, CD. There's the mechanism for ejecting. Look at that. The laser's trying to read. Let's see if we can get that screen working a bit better. So, let's see. Why could our screen be dim? So, I wonder what would happen if we power it up now. Will we get anything? Yes, okay, that's good. We have a screen. So, let's check our LED voltage here. So we have 6.5. Now let me lever this up a bit. And you can just barely see if I switch like power off. We'll switch it on. You can kind of just see the display shining through there. And it doesn't get any better through the extra pane of glass here. But what we're finding is I'm seeing light on this side, but none on that side. Now, what I can also see, if we look, we tilt it forward this way, I don't know if you'll be able to see that, I'll see if I can zoom down. This is a LED driver board, so there are 3 LEDs that provide the backlight for that vacuum fluorescent display. There's one here, there's one there, and there's one there, but it only appears that this one here is lighting. This one on the left, which explains why we're getting LEDs, why we're getting light there, but none on that side of the panel. So if we check, let's get the meter out, and then we'll check those diodes, those LEDs. So this one on the side that is lighting up is getting a nice 3 volts. This one in the middle that is not lighting up, 1.5. This one on the end, 2. So yeah, these LEDs are not getting enough to drive themselves, which is weird because all of that voltage is coming in through this connector right here, which is providing 6.5 volts, which, yeah, more than enough to drive 3 LEDs. So I think I may take this LED board out. It looks like it's just 2 pads there, and then it's held on with these clips. And we'll give it a test and see what we get. So we're obviously looking for 6.5 volts, but yeah. Let's do that really quickly. Okay. So, yeah, we have 3 LEDs, this white phosphor coating on them, ground on this side, and the positive on that side. Yeah, there you go. So we're only, let's bring it up to the 6.5 volts that it was before. Yeah, so only one of these LEDs is working currently. Now, whether that's the LED for the backlight, or if it's, maybe one of these resistors and capacitors has popped. But yeah, let's take one of these LEDs out and give it a test separately. There you go. There's why the backlight wasn't working. Well, this is my old LED tester. I believe there's just a 9 volt battery in here, which may or may not be good anymore. So I've just grabbed a blue LED to test that with. So throw it across the leads, and there's blue LED at 10 milliamps. So let's give this a try. And no, it does indeed look like this LED is kaput. Try 20. No. Yeah, no, totally dead. So, burnt out LEDs. I'm wondering what these look like in my component tester, if I can find it. So, let's have a look. It's a resistor. Yeah. Okay, so it looks like this shined pretty nicely white with that nice cover on there. So let's see if we've got something that we can replace it with. Probably not right now. I've only got 5mm blue. Yeah, I will have to get a white LED. Or 2 or 3 maybe, just replace them all. Well, there's that case sorted, but otherwise this seems to be working fine. So once I've got the LEDs that I can put back into here and replace those. I'm curious as to this cover. I'm guessing they're just white LEDs with yellow well, let's scrape this one back, shall we? So look at that. It is just, it's like a rubber condom over the top of the LED. That's funny. It really is. And then I wonder if we can pop this under our microscope and see if it's actually, it looks cooked inside. Guess I will get a couple of replacement LEDs, and then yeah, sorry, where I was going with that. This is working otherwise, as far as I can tell. We've got the display, it's opening and closing the drive mechanism, so I'm assuming it'll insert its CDs. Once I can get this back up and running with the LED board back in place, I'll clean off that amp board, run some CDs through it, see if everything, I'll clean everything first of all, put it back together, run some CDs through it, see if it needs anything else there. I was a bit worried about that belt needing adjustment, but the eject mechanism seemed to be working fine, so I'll probably leave well enough alone unless I can find an exact replacement, which, well, I'll have a look at my stash. But yeah, probably leave it at that for now until I get some replacement little 3-wheel white LEDs. Just a pretty interesting note. This little yellow, like I said, I called it a condom, was over there as a yellow filter because this is the LED that works. If I put that on the board here, and it does actually need the 50 milliamps, it comes out white. If we lift that off and put it back in, it's actually a blue LED. Ha! So that takes a blue LED and makes it white. That's pretty cool. Anyway, so I guess I'll find a 3mm blue LED and put that in there instead, and just yeah, put the little condom back over the top. Neat. Alrighty, welcome back. It's been a day. I've been for parts. Now what we have here are 2 types of LEDs to replace this. I got some blue and some white. I can't remember which is which, so I'll have to give those a test. But I figured with the blues, I could either take the little yellow condom off and put them on and just leave it kind of as is, or we could move into the future and use an actual white LED. We'll see how they look, I suppose. The other one that I got was some replacement capacitors and fuses for the power supply. Now, you might be noticing that I have 2 capacitors here when that only had 1. And the reason for that is I spent a little bit of time last night in bed reading the service manual for this. You know, as one does, a little light bedtime reading. There we go. And this comes from that fringe era just before they stopped including circuit diagrams in service manuals, or even producing service manuals at all, but it definitely has it. And now it might not be a little bit easy to read because this is supposed to be landscape, but what we can see here, and I'll probably flash this up on the screen, is the fact that the circuit for the power supply for both, so these little tables here indicate what we need for US and what we need for Australia, Europe, or UK. And all the differences is this right here is the capacitor on the inside and the fuse. So the fuse changes from a 125 volt rated 3.15 amp to a 3.15 amp 250 volt rated. And the capacitor that's there changes from 1 220 microfarad 200 volt to 2 100 microfarad 400 volt. Otherwise, the entire rest of the circuit stays the same. So the switch mode supply in here can detect that additional voltage based on this and just work at the high voltage. It's just those 2 support components at the start, the fuse and the capacitors, that need change. So I got a couple of 100 microfarad 400 volt capacitors. And I don't know if you remember in there, we'll show you in a moment, that it had the slot for the capacitor that I replaced, and then there was just an empty unpopulated spot off to the side. So we should just be able to pop both capacitors in, upgrade the fuse to one of these new 250 volt ones, and just work. So then what I'll be able to do is use it, I'll test it with one of these little universal testers. I can plug it straight into there, and then that's straight into my circuit breaker, and we'll see if it pops again. If it does, then, well, bugger, I'll just go back to the capper that's in there now and is working. But I think for starters, while I've got it apart, let's change the LEDs over, and we'll replace all 3 of these LEDs with a new one and see how we go. So let's see what we've got. Now, what color are you? Tester here, and you are blue. Okay. And then these ones would be white. Yes. So there's our white. And it's a pretty nice white. Fairly white. It's a little bit of a blue white. But what we'll do, let's grab, was this the dead one? Yes, this is the dead one. So let's grab the little condom thingy off there and pop it onto this blue one. And it fits nicely. Okay. And what color do we get now? And yeah, it just gives that same kind of white. And it is a really nice filter. Like, it's not overly bright. It actually dulls it quite a lot, which compared with the actual white LED leaves a really, really bright spot. So I think going with the blue LED and transferring over the little condom thingy, which diffuses the light evenly for the backlight of the LCD display here, I think that'd probably be the best option. So I'm going to go with that. So yeah, okay, let's put the white one away. Let's get the third. I've got 1, 2, 3 new blue LEDs. And yeah, let's get installing. We've got a really nice little silk screen on here that shows where the anode and where the cathode is on each of these LEDs. So it should be, if I remember correctly, is the short lead that way. So what I'll do, and looking at these LEDs, they need to be a little bit shorter. So let's just drag those into about there. That looks good. Well, you know what, let's form them the way that they came out, so like that, and then we'll bend them out at about the same leg length. Let's get our power supply back in. And we got power here and ground here. Ooh, got one backwards. Did one backwards. There we go. All the LEDs back. So now we just take those little filters, put them on the LEDs. We get a really nice even backlight. Yeah, great. All right. So let's clip that off, tidy it up, and put it back in. All right, and then we'll just solder those two connections back on. Yes, that is a backlit display. Look at that. So now if we turn you on, oh, beautiful. It's even a little bit too bright maybe. So we might want to look at changing the resistors on there, just to dull those LEDs down a touch, because they are getting driven quite hard, it seems. Yeah, that's a bit too bright. So yes, I think I will do that. Okay. On the back here, we have, and I remember this from the schematics, but each of these LEDs is dropped by a 150 ohm capacitor, and you can tell it's 150 ohms because it says 151, so that is 15 and 10150 ohms. So let's increase that value, which will drop the amount of current driven to these resistors, which will make them not quite as hot, not quite as bright, and last longer. So we're at 150 now. I think they were, honestly, I could do the maths on here, but I'm not going to. I'm just gonna eyeball it, I suppose. Not really an eyeball, but yeah. They were about twice as bright as I'd want them to, so I'm gonna shoot for twice the resistance. Why not? I know it's not linear scale like that, but round number, let's just figure it out. Okay, here's my little black book of SMT components. So we're looking for about a 300 ohm. So we got 27, we're in the K's there. So on this page we have some 0805s, 330, 150, there's 150. 330 sounds good. Let's try a couple of those. Yeah, that's much nicer. So when we turn on, we can still see it. It's still very bright, but you can't see all of the other symbols shining through. Oh well, I mean, you kind of can on the camera, but in real life, and especially when it's behind this screen eventually, I think that is nice. Stand by. Yeah, that's not too bad. You could probably dull it down a little bit more. I dare say these LEDs are a bit too warm for how this was, but I'm pretty sure there's a dimmer. Yeah, look at that, when it goes into dim mode. That's really nice. No, I like that as is. I'm going to leave that. Cool, okay. So now, let's turn this back off. There we go. And now we want to tear the whole thing down again so that I can get into that power supply and we can give these power caps a try. Well, I got to this part of the teardown and I realized a fatal flaw in my plan. So these new 400 volt caps that I got are too damn tall. They're sticking out like a good centimeter above even this one that was too tall, and that's the one that was there before, and you can see it's nearly twice the height. So these will not fit underneath this cover, which sucks. So that means we'll need to actually order some special ones. So these are a pretty average brand as well. Topcon, I don't know, they were just the ones I could get at the local electronics store. So I'll probably need to order some good Nichicons of the right height. Yeah, that's okay. I can always just put these in the hood and move on. Yeah, so I guess I will put this back together for now and see about getting a better sized capkin. Okay, it is a few weeks later and I got the bag of caps from Element 14. It looks like they shipped them, judging by the cancer warning here, from America through Malaysia and to Australia. And we have 200 microfarad, 400 volt snap-in caps, and let's just compare them to the 200 that I took out, and they are. That's a pretty damn good match, I must admit. So, now, as you can see, this is mostly back together. I just put it back together to do some final testing. That is with the 120 volt circuit. So let's tear this down, get these guys in, and let's test it on mains 240 volt in Australia here. Yeah. Okay, and we are back to the power supply. Okay, so let's get that, it's the 200 volt cap that we bought. Pop that, oh no, we had that one in the stock, that's right. So let's get that out, and let's put our two new guys in. Out with the old, and in with the new. So let's just clean up the holes on the other part as well. They look like they were previously filled with solder from the factory, probably just during wave soldering. Alrighty. Now, on the upside here we should see, there they are, we've got some positive markings. So, negative goes on the opposite, obviously. One should snap in, and the other should also snap straight in. Cool. And solder this down. Now, the final thing that we need to do, which I need to not forget, is to change out this fuse, because this fuse, if we can read the markings on there, is a 125 volt fuse. So that would explode very quickly. But thankfully, in the little baggie that I got from the local electronics store, I picked up a pile of, should be matching ratings. Let's see if we can get it there. 3.15 amp, 250 volts. And this is what matches on the data sheet, on the service manual, sorry, for running this power supply in 240 volt or in 240 volt regions. So that should now be done. So what I'll do is I will not plug this into the entire unit, but I will plug it back into the power connector here, and I'll just run it up as is without a load, so without the circuit board and everything. And pretty much what I want to see, this is just a sanity test to make sure it doesn't explode. And I will be running it through the same lead, so I'm going to need to clip this lead off and wire up a Australian 2-prong connector on there, but that should be pretty straightforward. For now, I'm just going to run this through a simple converter. So what I can do is I can twist the lead, so that's the Australian configuration, and then the US will plug into there, and this just does no power, it's just a straight pin conversion. This is one of the ones that I take when I'm traveling. It's got Europe and UK and all sorts. Very handy. Very dangerous as well, but neither here nor there. Okay, let's give it a shot. And by shot I mean test, not explode. Please don't explode. I will of course be running this through my little circuit breaker, just in case. Okay, here goes. Alright, that's got power now, and that's on. Okay, nice and safe, I've got it insulated. Let's check some of those voltages. So, just got the voltages marked out here. I just want to, now that I've confirmed that it is taking 250 volts and not exploding, let's just check that it's actually, switching, being a switch mode power supply. So we're back on. So I'm going to be very careful because this is all live down here. And we're going to check between A ground here and minus 7.5. This is the analog rail, so we're seeing minus 7.2. That's close enough. And positive 7.5 on the analog rail, yes. And then we'll check the digital ground against I think it's the 15 volts is down here. Where is it? That's minus 15. There's our 15 volts. Perfect. And we should also have 10 volts there. Yep. Okay, cool. So the 5 volts is generated by this other little subboard that I haven't plugged in, but we're getting all of these, so as far as I'm concerned, this is working. That 250 volt conversion by adding the fuse and the two higher rated caps has worked a treat. So this should now run natively on Australian mains, which is fantastic and will be great news for its owner, not having to use a step up transformer. Step down, yeah. Sorry. Anyway, yeah, let's get this back together. I might give it a bit of a clean up and lube some of those rails because it's pretty old. Yeah, get it back to its owner. Yeah, that's a lot of miscellaneous oil and crappy old grease. This belt feels pretty good though, so let's see about tidying that up. Well, at least the grease is still good. Didn't necessarily need a change, but while we're in here and we've got it torn down, do it anyway. Mechanism works pretty well. Yeah, I'm not entirely sure I want to mess with that. That seems like it's already pretty smooth. What I might do is just refresh the stuff that I can get access to really easily. So let's just wipe down the dirty stuff on the outside. The internal mechanism feels pretty good, because that's coming up with dust and grit and grime and junk. So okay, now I'm going to relube this mechanism with some super lube. This is a PTFE synthetic grease. There's no petroleum products, so it won't just degrade the plastic, and this stuff basically never dries out, so it should actually outlast the grease that's on here already. And I am just going to use a toothpick. Collect up a decent glob of it and slaz it on. I'm just going to kind of reproduce the schlazzing that came out of the factory in the same spots. So this bar, the rail that it slides on there, all this here gets a good slazzing. Last one that I want to clean up is the pinion under here, so I'm going to run this until it opens all the way. Like so. And I'm just going to clean all that grease out there as well. Grease on everything. Okay. There is our completed unit. Nice and back together. Now, last thing I want to do, just before we pop the back on and give it a final test. Now, our little label here does say AC 120 volts, and that is now incorrect. It will not run on 120 volts. But what I've done, got my little label maker, and I made a little 240 volt. So, let's just trim this to length. And I'll pop that in place. I think that's pretty good. 120/240. Now theoretically this should actually still run on 240 as well. If I'm reading the circuit correct, it's just going to have a lot of extra capacitance and the power supply may not start up properly, but theoretically it shouldn't explode or anything like that. It may just not run very nicely. So it's never going to see 240 volts, so I'm not that fussed about that anyway. And then this goes back on the unit right there. Good. So let's give it a final power up, and I might move my camera angle here so you can see what's going on, and let's give this a test. Okay, we're at the end. As you can see, the unit is together. It is all back and nice, and I've given it a really good polish and clean all over, lots of grit and grime as we saw. I've also polished up the cable, so I've changed the plug that was on the end to this Australian 3-pin adapter. I'm not using the earth obviously because this is only a 2-wire, but it's just as good as it was. And I think I've also changed the LED in the backlight. We moved that back from 330 ohm to 1K so that it's a little bit dimmer, just a little bit less washed out. But yeah, got on the bench. I've got it hooked up to my 3D printed licorice all sorts. And yeah, let's Give it some power. There it goes. Look at that. Looks fantastic. Power on. We get all the different functions. The tuner. Don't have any headphones in. The tape works great. And the CD. If we hit eject, you can then pop a disc in. As you can see, that mechanism is working excellently. Nice and greased. And as you can see, it plays perfectly. So I'm pretty happy with this. I dare say the owners are going to be happy with this as well. So I'm going to bag this up and get it back to them. Hopefully they enjoy it as much as I am. But anyway, thanks for watching.